Okay. Did all my push-ups. This is stream number 186. It's Wednesday. It is 11:42 p.m. It is almost Thursday. And we need to fix this little artifact right here. So to fix that, the square we use to kind of erase this section of the circle has its origin who knows where. And one way to fix this is if we can get the origin of the square to be the top left corner of the square, and then we put it at the center, and then we rotate it by, I believe, 30 degrees, then it will be erasing where it needs to be. But I do kind of like how it's kind of like straight down right here. I like this straight down horizontal here. So we want to make just another eraser for this shape here. So if we're looking at, so if we're looking at all the crap for doing this, chop the snout, and then somewhere in here is the circle, right? So here's a wheel for the horn, and we're differencing it with something. Okay, yeah. So what we're going to do here is we're going to just say, we're going to put this into its own thing, right? And we're going to call it ZODIAC Aries horn, right? So kind of like a sub function. And so when we're trying to look at this Aries thing, we can put this over here as kind of a subcomponent of, right? So all these subcomponents will be in this kind of like arrowed section, which is something I haven't done in a while, but this is how I usually do it. And then what we can do is, right, module ZODIAC Aries horn SPC, and we're not expecting to change anything yet. We're just expecting that we have a nice little refactor, but it looks like we do need to. We have an imp horn rad, which needs to be turned into like a top level kind of thing. Yeah, so what we're going to do here is for imp horn rad, we'll just say zot imp zot Aries, we'll call it Aries symbol constants. Right, so in here, we'll make a note, Aries symbol consts. So these will be, these constants in here will be specific to the Aries symbol, right? Because we plan on probably using this to create other zodiac tables. But this is the first one we're working on, right? So Zot Aries, and then we have the imp horn rad. So we'll just go like imp horn rad there. And right now that's like 0.8 for the radius, 0.8 inches because imp is for imperial. And then imp horn rad right here, we can just do this, right? We could do that. And then over here, do you have enough room? No, that just makes it harder, so yeah, that's what we'll do. And then over here in this function, right, we just gotta do the same thing, right? So imp horn rad equals, you know, this top level constant. Now if you do that and do F4, now the code once again works. Okay, so the cool thing about that is now we've isolated part of the problem, right? So in here, if we just want to do the horn, right, if we just want to get rid of the Aries symbol for a second and just isolate it to the horn, right, we're going to see that, or not. Okay. Hold on. Oh, yeah, because we have to do SBC. We got to include the, oh, wait, and it's not just called at the top level, it's ZOT SBC. So it's like a configuration object. Okay, so you see how we kind of chopped this, right? And that's all good and well, but we need to chop it a little bit here so that right now we're getting like a little artifact like right here, because we're trying to create this tangency, right? And coming off of here with a tangency, we have to slice it like that. So to get that going, to get that figured out, the first thing is we can look, well, how did we chop it before? How do we chop this? And we have this thing that is, so here's our pocket that we're using to subtract stuff from. We're using this imp horn radius. We're going to have to figure out what degrees everything is going at, right? So this is the angle, which is like 280. And 280, so 180 is a full circle, 280 is somewhere over here, right? So 280 plus 90 is what we need. Okay, so the first thing is this angle here, we might as well, it's the head angle basically, what that is, that's Zod Aries ang. Right, so that's the head, like those two lines that make up the head. That's the 280 degrees right there. So we'll just kind of put this in here, as you know, right there, right. So just a little bit more refactoring, and then we also want to make sure that that's correct. So if we put this back in here, right, we should see the whole thing, and that looks all good now. So we'll comment this back out because we still want to figure out how to fix up these horns. And if we look at now that we have this kind of angle, right, this head angle, we should be able to horn delete angle equals this plus 90, right? Because it's perpendicular, right? It's the vector coming off of here, right? The vector coming off of here, we need something tangent. We need this to be perpendicular. Does that even make any sense? I don't know if that makes any sense. If we have a line that's coming off of here, then if there's a line that tangents this circle, right? If there's a line that tangents this circle, then if this line tangents the circle, if we go by a 90-degree offset to create a line from here to that line that's tangenting the circle, right, we need a 90-degree offset, right? We need a perpendicular. There's a relationship between perpendicular lines and tangencies, if that makes sense. I can't really describe it in my head, I just know it's correct. But anyways, so we're going to use this horn delete angle, and we're going to just do another difference, right? So we're going to difference, okay, original horn with artifact. So this is the original horn with artifact, right here. Okay. And then remove. So we're going to remove the artifact right here. Okay, so to remove the artifact, we'll get to that, but hold on, let's make sure that there's no syntax errors. To remove this artifact, we need to create a inch pocket, SPC. The exact size we need to use, I don't know what it needs to be. We could do the horn radius, I guess. Maybe the horn radius times 2 and the horn radius times 2 might be enough. So let's say horn radius, and the thickness is 0. I don't know why I gave these pocket functions thicknesses in the first place, but I did. And okay, so we see these little things right here, these little cutouts here. Well, we want to translate here to here to get this at the origin, right? So we want to go to the right, and then we want to go down. Okay, so we're going to translate this. So inch xy SPC imp horn rad divided by 2, and then imp horn. This is offset xy. Alright, so offset xy equals imp horn rad divided by 2, and then we're gonna go forward and down. And if we do that, we might not see anything anymore because of the fact that it's completely in a erased area already. But it's part of what we need to do. So let's do this, and now, yeah, we don't see it anymore because now it's like right over here, right? And we need to rotate it by this deleter angle, right? So now we have to rotate it, and then rotating it actually will probably be just enough. That'll probably be all we need to do. So we just need to rotate on the X with this delete angle, and that should be, and not on the X, sorry, not on the X. We need to rotate it on the Z. We need to rotate it perpendicular to the Z. We're doing stuff on the XY axis, so the vector for the rotation angle is just on the Z. So F4. Okay, so that's cut in kind of where I expected it to be, well, where I want it cut in, but I guess this this radius isn't quite enough. So deleter span is going to be this, and then we'll just throw this in here like that. And then the offset XY is going to need to be whatever the del san is. Okay. F4. Or, I don't know if I pressed the right button. F4. Yes? No? No? I don't know what that was about, but somehow we've screwed this up. So let's go over here for a second. So the delete span, imp horn radius, oh, not divided by 2, times 2, my bad. We wanted to make it bigger, not smaller, because it wasn't, there we go. Okay, cool. So see, we got this kind of chopped off at this angle, and that's intentional. So now, if we go back to, if we go put this all back together, right? So let's get rid of the horn. Let's just comment out the horn code, right? So comment out the horn code to remove this, and then put in the entire zodiac symbol. And if we do that, right, we can kind of see how the geometry goes together. But you'll notice that there's no artifacting here, right? This goes nice and tangent into here, right? This part goes nice and tangent into here. So now when we render that, see, we got nice, we can zoom in there. Perfect, nice and tangent, right? So everything's nice and tangent. I'd say that's a pretty good job. Now, the only thing I could say that maybe we could make a little bit better is that maybe this part we're kind of deleting the snout. Possibly it would make more sense to delete over here so that this distance here is a little bit more right, the distance between here and here and here and here isn't quite the best, right? That, or we could try to, instead of 2.3, right, we could bring it down more, right? So instead of 2.3, we could try like 2.5 or something, right? Just try to offset it differently, right? If we do that, actually that looks better, right? It already looks better because the distance is here. We could try 2.8. That might be too much. So that's too much, right? Because now look how close this is, and look how close that is. So 2.8, not quite good. 2.5 maybe. 2.5 is actually pretty good, right? This distance here and the distance here, they're not bad, right? It's not perfect, but hey, it's art, right? So It's not mathematically perfect. But I like that, and then also, yeah, I think that is it's well centered, if that makes sense. It's well centered. So the next plan, what is the next plan here, right? So, okay, so you made this zodiac kind of symbol thing, and you wanna keep it like in the middle, like this, and the thing is that we want to just try this very coarse level of detail before we try to make a zodiac table with like a whole bunch of little symbols on it, right? And the reason I chose Aries was because I'm thinking, okay, well, what month is it? And how does that apply to, like, what zodiac... Like, when people are looking for gifts, they're going to look for, oh, this person's zodiac sign is this, because I'm going to get them a gift, right? And so people are probably going to buy gifts for if people are buying gifts that have anything to do with zodiac symbols, they're probably going to do the zodiac symbol for the current month, or the previous month, or the month after, right? The previous month because, or sorry, the zodiac symbols aren't exactly on month borders, right? So people, if they're buying gifts, aren't buying them far in the future, right? So you need to find the zodiac symbol that's closest to the current date, or if you're trying to release the if you're trying to figure out a zodiac symbol to release for like a product, and you don't get to choose all the zodiac symbols, then you want to choose one that you think people are more likely to pick, right? And likely, that is going to be on depend on what month it is, right? So Google Analytics by month. Can we find a Google Analytics by month? Monthly data. Hourly, day, week. So yeah, let's go look at Google Analytics. So Google Trends. Actually, no, I want to look at Google Trends. And I don't know if we can do it on a month-to-month basis, but I bet if we just look at, Aries, and it's a zodiac symbol, we should probably see like some type of fluctuation based on, it's actually pretty, right? Not what I expected. Well, over time, past 12 months, past 12 months. So Aries is this month, right? So March. I can't really see a visible spike in here. I mean, I see these spikes here, but they're not March. November, December. March, April, huh? There's actually a dip. There's actually a dip on... Well, actually, hold on. It's a local minimum. But if we look at this whole line here, right, it's actually... We can see a little curve going like this, right? It's not that pronounced, though. It's actually not... I was gonna expect more. But let's just try Virgo. Let's try more of them. Let's try... Oh, actually compare it to Virgo, right? So Virgo. And does Virgo have like a peak in... Actually, it has a peak way over here. Is Virgo August? Zodiac signs and month. Is Virgo August? Virgo is August. August is in September. Okay, cool. So if we look at that, I was like, hey, is it August? Bam! Look at that little peak. Okay, so let's try something like Pisces. Or, no, Capricorn. Capricorn. right? And if we look at Capricorn, we see a little spike right here in December. December or January? Okay, well, let's go look at the zodiac signs. Is it December or January for Capricorn? December and January. Nice. Okay. So how about let's try Cancer. Oh, well, no, Cancer is like, you know, having cancer, right? So I don't know if that's going to work as well. But we could try that and see if we also see a spike. But I don't know if Cancer... Yeah, so Cancer is kind of an outlier because it's not just for a zodiac symbol, right? It's for other things as well. But Sagittarius, though, I'm going to guess is pretty much used only in the context of a zodiac symbol. And we can see this, and then we see a peak right here, and then we see a fall off, which is kind of weird. But if we look at this, okay, November. Okay, November for Sagittarius. Is that Sagittarius's month? Let's go look at this, and Sagittarius, November, December. Okay, so far, I mean, except for Cancer, because it's kind of has other meanings. How about Gemini? Can we look at Gemini? Okay. Actually, I didn't want to make it all capital. I don't know if that's gonna... Gemini might have another meaning, because I'm seeing a peak and a peak. Yeah, I'm seeing two peaks, which means I think it might have another meaning. But we're either thinking May or October for Gemini. So May or October for Gemini. May, June. Okay, yeah. So I'd say that, that this is... it's rough, but my hypothesis that, hey, you know, if people are buying gifts, they're probably going to be searching for gifts around whatever month is associated with the zodiac, if that's what we're doing here. So we want to kind of focus in on the current month. So Aries is what we're making. Aries is what we're making because right now it is... well, actually, we see the peak in April. Aries, March through April. Yeah, okay. So Aries, and the next thing we want to do is we want to start making things in order and try to get ahead of the curve, if you will. Okay, so cool little hypothesis, proven. The next thing we want to do is figure out a plan for... We'll just keep this dead simple, and that's just the whole thing we'll mill, right? We'll mill that, and then we'll plane it. We'll mill it, we'll fill it with epoxy. We'll, like, V-carve it, fill it with epoxy, plane it down. Maybe, maybe not. And for this, I'm looking at, where do I want, like, locator pins? So the actual locator pins that I would like for the tabletop would be these middles right here. So these bolts are actually going to be used to hold together the frame, and these middle sections don't need to be present to hold together the frame. So these middle bolts right here, there's no middle bolt here, but I made a different angle piece to correct that. But these middle bolts are what is going to be used to support the frame or locate the frame. So I would like to design some locator holes for this, and I think V-carving these locator holes could actually be good, because they could be like they could be slightly funneled. So we need to think about how we're going to design how are we going to do the cutting sheet, right? I don't know. 20.75. So this is 20.75. The current piece of material I have is 2 foot by 2 foot. So there's going to be a decent amount of overhang here. So that's important to remember. The distances between... So this is 5.25, and then here's another quarter, a quarter, and then a half of a quarter to get where those holes are going to be exactly. Now, if we get this wrong, we're gonna be hurting. We're gonna be in a lot of pain. So it would be nice to, and I'm pretty sure I trust my writing here, but let's not trust ourselves, anyways. So let's look at this for a second. 1, 2, 3, 4, 5, 6, 7. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8, plus some unknown amount in the middle that we can't tell, which would be 8 plus 9, 10, 11, 12, 13. 8 and 8 plus 1, 2, 3, 4, 5. 8 and 8 plus 5. Is that correct? Yeah, I'm pretty sure. 8 and 8 plus... Oh, no, wait. It's going to be 8 and 8 plus 3. 8 and 8, because this is 8, and then this hole right here... No, it looks like 8 and 8... See, I don't even know. I should probably just trust that I know what I did here. Right? Trust my measurements. So this 6.5... Yeah, let's just hope that our measurements here are right. Right, if our measurements on this blueprint are correct, then we're good to go. Now this is also why we might not want to use very expensive material for our first run, because what if we put these holes in the wrong spot? So let's just assume that imp dist between locator. So the distance between locator holes and imperial measurements is 6.5 according to this. And yeah, so let's just keep that, and then when we're trying to let's do like module zotcom cut table Aries, and then let's do like SBC, and then what layer and what side. It's not really a layer, it's more like a pass, right? If we keep it just, if you can keep it down to just one pass for the top, one pass for the bottom, then we don't even have to worry about it, right? We can just say, Aries top, cutting path index. So we're going to call it cutting path index because I don't actually know. I don't know enough. I can't see far enough in the future to know what these indexes are going to stand for. Like, what's the top? What does a top cutting path mean? What does a bottom cutting path mean? What does it mean if I say it's the top cutting path and we cut the top of the material, but then we flip it over, and now that it's flipped over, that's actually the top of the table, right? Like, there's too much in here for me to know exactly yet. So what we're going to do here is we're going to put this kind of stuff in here, and we're going to say that, you know, if the cutting dex, and we're going to keep one-based cutting indexes. So if 0 equals cut dex, echo using one-based cutting indexes. Right, so if it's like this, yeah, else if 1 equals the cut dex, we'll actually keep kind of this frame thing here, right? And okay, so that's gone now because we have to actually put it back in. So a ZOT SBC, so the SBC, the shopbot constants for this specific file is what that is. And the cutting index is 1. Okay, so now if we put that back in, we'll see kind of all the work we've already done. And the frame itself, we're not actually going to make a path around here, right? So that's more like a debug thing, right? So let's just make debug config up here. And we just want to say, you know what, having that border is kind of nice to know about. So just say, you know, ZOT debug show table border. And we're going to make that a 0. And then we're going to go find where we're making that border, right? So in this cutting table, right, we have the wheel frame, which it has the wheel within it. But then somewhere, boy oh boy, look at all this commented out code. Let's, any commented out code we'll just delete right now, because it's just cluttering things up. And this is a frame. So it's either this thing or it's this thing, but this frame has a zero thickness, a 0 width on one axis and a thickness. So we're just going to put this here. We're going to say, you know, if greater than or equal to 1. So if that debug setting is on, we will actually show that, right? Now you might be like, okay, well, in the laser cutter, we need kind of like a border surrounding things. But in the shopbot code, it's a little bit different. Everything just has an origin in the center. We'll just have to we'll just have to paste and align stuff, which will kind of suck. But yeah, setting up the shopbot file kind of sucks, but it's a little bit harder than setting up the laser cutter. But there's different settings, right? Because the laser cutter you could think of as 2D, but you could think of the shopbot as like 2.5D, right? Because it's mostly a 2D path, but then you can go up and down on the shopbot, right? You can plunge and you can make patterns that have like a surface that kind of ebbs and flows up and down. So there's more dimensionality to it, and therefore the setup is a little bit harder because it's more complicated, right? More dimensions, more problems. How about that? Okay, so that's good there. And let's just make sure that debug setting does work. So if we toggle this back on, we can indeed see that, right? So that's just like for when we're working on it and we want to make sure that everything looks good, we can use that setting. So the next thing we want to do is else if 2 equals the cut dex, and else echo cutting index too high. Else, if cut dex, my bad. If it's greater than 2, else echo null cutting index, likely. It's not necessarily a null cutting index. There could be something else wrong, but if this doesn't catch it and this is the last thing that catches it, then that's likely the problem. Okay, make sure we didn't introduce any errors. And now we just want to, right, we have these holes. We want to start positioning those holes, right? So we're going to take this distance here, this imperial distance, and we're just going to say ZODIAC locator holes, something like that, right? And this shouldn't be ZOT SPC, this should be SBC. So over here where this says ZOT SBC in these two places, this needs to be SBC. So the reason why we have it this way is because we're coding in kind of a more... It's an annoying way to write the code, because to always pass this configuration object, but if we want to get serious and kind of combine this with other code later, we're going to have to write it this way. So we're kind of like rebuilding all the function files that we cut and paste, which is nice. We can't afford to be doing it that way because of just there's just a lot of complications when we want to start combining different files together, and I want to start doing that. Maybe I'm wrong here, maybe I'm being stupid, but try things different ways, right? Try things different ways, because you might find out something, you know? So, module, right? Module, ZODIAC locator holes, takes a thing called SBC, and then we drill in those those holes somehow, right? So if we look at this, we got nothing. But we're going to change this to 2, right? And now we really got nothing, right? Because now we're not even going to see anything. But now the next thing is, we know how much to translate by, right? Because it's this variable right here, distance between locator holes, and that's imperial. So we'll just call it imp dst, right? We'll just shorten this variable, because this is the only distance variable we should be using within this function. And that's the nice thing about breaking things into other functions, is that you can kind of shorten variable names like this, because the context, the scope of the context has been quite short, is more specific, right? The context is so specific that you can use even terser, more generic variables, because they're usually generic variables, but they're within a very specific context, and therefore they're, right? Does that make sense? Probably doesn't make sense, right? Distance, the only thing distance could mean within this function is this. Now, if we had locator holes and, I don't know, pretzel holes and cheese holes, we had all these different kinds of holes, and we were going to drill those different kinds of holes in one function, without any subfunctions, then we wouldn't be able to call this imperial distance, because is it the distance between locator holes, the distance between cheese holes, the distance between space holes, etc., right? I'm just making up facetious hole names, but you get the idea. So we have a, we want a vcarve inch pocket. Actually, vcarve inch hole, because we want it to be a circle, and we want that to be like for the head, it needs to be like a about a half of an inch, I believe. We actually could take the time to measure a bolt really quick. I might want to measure a bolt really quick, make sure that's correct. Okay, so I have a bolt. Okay, so I have a bolt, and when I measure this bolt, I can kind of see that it's not the radius of the shaft that we want to look at, because the table's actually going to rest on the hex head. And it looks like that radius is about a half of an inch. But we might need a little bit of wiggle room, right? We might need a little bit of wiggle room because Tolerances, right? Tolerances and things aren't pixel perfect, right? So I'm thinking, or we could just make it that, and then the table will kind of naturally kind of, if we V-carved the locator pins, right? If we use V-carve for it, and then, well, if we V-carve those holes, then we probably need to start even bigger, right? So I'm thinking, a 1-inch diameter with the slope that goes for 1/4 of an inch, and that way when you try to put these holes down, you have like this kind of funnel thing that makes it really easy to put these down. So what do I mean by all that? So what I'm thinking is something like this, like we have a assume that this is 1 inch here. Okay, 1 inch. And the hex head is like, kind of like over here, like this. And maybe not the best. Not the best hex head diagram here. But let's say that let's try to okay. So there you go, that's a little bit better. Okay, so this is just going to be a very crappy kind of hex head. But the dimension we care about here on my crappy hex head diagram on this crappy little hex head, and yes, I did spell hex head incorrectly, but the idea is that I want to be able to look at this, right? Is that this span right here is 1 inch, is a 1/2 of an inch, but we want to right? It's when we're drilling the little funnel for where this bolt is gonna rest, it's gonna bottom out here, but the hole itself on the exterior of the hole, the exterior of the pocket is gonna be this big, and the interior of the pocket is gonna be this big, and this is a sloped region, and this is a sloped region, right? I know this is like a one-dimensional view, and I'm kind of describing something that's three-dimensional. But the idea is we have this like sloped pocket that makes it a little bit easier to locate where the tabletop goes. Okay, anyways, so if we're doing that, then we're saying that imp outer hole, outer pocket diameter equals 1 inch. All right. So that's this. That's that 1 inch from the diagram. So we might want to write 1 inch here, so when we highlight these, we can see them kind of connected. And okay, so here's this distance variable. Let's just call this right here. Let's call it imp dia. Right. So outer pocket diameter is what that is. Okay, so that looks a little bit better. We got the diameter, we got the distance. And so for this thing right here, for this this hole, we're just going to say that the hole has a imp dia divided by 2. And then it's... am I missing anything, or is that the only thing I need? Maybe that's the only thing I need. I don't know. I feel like we need more things just because... oh, and we screwed that up. This needs a... We need to end that comment. Okay, there we go. So we got this little hole thing here, right? And so the idea is that when we're making this pocket, right? It's the pocket on the exterior. When we start milling, is going to be this big, but then at the maximum depth, it's only this big. So as we mill, so there's a slope. There's a slope, right? So it's just easier. It's going to be easier to put the table down, right? It's going to be easier to locate those pins because that makes those. It makes the holes bigger, right? It makes it easier to slide the table into place, and then also it could create a little bit of clamping pressure to make the table fit nice and snug and not like wobble around and whatnot. This is all kind of hypothetical, but okay. So we got these locator hole thingamabobs, and we think it's like this is the circle we want to use. We want to put them in all these locations, right? So the first thing we should probably do is it's these holes here. So let's just make all the holes around here first, and then we'll go from there, right? So if we look at the math for this, inch xy, right? And we got to give it the configuration variable. And we're just going to be like imp distance dst, imp dst, and that should put it up in that upper right here. And then what we can do is we can just mirror. We could, but that's just... Okay, first of all, let's just shorten this. So d equals imp dst, because I just don't want to have to... I don't want to have to put this on a different line, because basically we're going to do this 4 times. Bam, bam, bam. And with different signs to do all the different quadrants. So we have a plus plus, we got a minus minus, we got a plus and a minus and a plus, right? And I don't know why well, I guess maybe that... I don't know why I indented that. I don't think that's really necessary. Okay, so we go back here, F4 for a second. Okay, we see these, right? And so we're just going to hope that those are appropriately placed. We'll take some thought as to if they are later. Well, actually, no. Let's think about that right now. So, if we do the locator holes right here, right? And then we just cut the first layer, or the first cutting path. I would say that's a problem. I would say, this covers the whole table. What's up with that? So 6.5, right? 6.5 should get us, like, right to here. And here we are, like, whoa, way out there. So, imperial distance between locator holes. Okay, cool. Imperial distance between locator holes. And D is this distance. That just doesn't seem right at all, right? Does it? Right, let's also debug. Let's also put in our debug show the border thingy, right? Because now I'm like, whoa, what the heck, right? So yeah, it's hitting the so there could be a few problems. One of the problems could be that their table just is not the right size. So if we look at the frame size that we've chosen, we chose 6.5 times 2. And if we want to look at this, 6.5 times 2, that'd be from here to here, right? So this circle is hitting these midpoints right here, right? It's not the whole thing, right? So the whole thing would be like 20.75. So what we're going to do here is we're just going to duplicate this and say, oh, well, you know what? Part of the reason why things look wrong is because we don't know what we're doing. But yeah, 20.75. So if we just do table span. Let's just say TS. 20 point table span in inches. And then we'll have to decide, is this an acceptable... Is this acceptable? Is this acceptable to us? In terms of the size of this zodiac thing, and that actually makes sense, right? Because we don't want to have all that intricate detail right at the edge of the table. So if we do this, okay, now we see a kind of a different story than last time, right? Where it's like, oh crap, are we okay with it like that? Well, the nice thing is that if we're sitting around this coffee table, we could have people set their stuff here and not set it directly on the glowy part, which would be kind of nice. You know? That could be a nice feature, actually. It's also less cutting. It's less cutting. It's less epoxy. So maybe we should just go with that for now and just see how that treats us, you know? But okay, that mystery is solved, right? We understand why that didn't look quite right. Well, I don't know if the mystery is completely solved. So this distance between locator holes, does that look correct to us still, or does that look like a problem? 6.5 should be the distance between locator holes, so from here to here, right? So if we're going here, the distance from the center to the locator hole is half, and this distance here is not, right? So we want to do h for half divided by 2, half distance. Okay, now if we do that, then these holes will kind of be more where they belong, except the variable d no longer exists, so we got to put that back in. Okay, so now if we look at this, where are those holes ending up? Not bad, not bad. Actually, that's pretty good, right? Because these locator holes, we don't want them to interfere with wherever this epoxy is, right? If they interfere with where the epoxy is, then we have trouble on our hands. So that's actually a good location for them. So it's these holes right here that we're looking at. Or at least that we think we're looking at. Hopefully we're looking at. So the next thing we want to do is from here we want to add boom, boom, boom. We want to add these, each quadrant. So to do that, we should just want to add these up here, like add on the X and Y and get these ones, right? Or get these 3, right? We want to add those 3. And then we'll just rotate, we'll just mirror radially 4 times. So what I'm saying here is we want to go IXY SBC, and then 0 plus H, 0 plus H, right? So start off from where this was originally. But then in here, we're going to go the full distance, right? So the full distance from here to here, right? Yeah, the full distance this time. So d equals imp dst times 1, full dist. So this d will be the full distance. And we just want to take, well, we need 3 of these, right? So why don't we just take 3 of these and paste them. And then within here, right, we know they're going to be called d. And there's one of these that we don't need. And the one we don't need is, we got positive, positive. It's the negative, negative we don't need, right? Or actually, none of these are quite correct, right? The positive, positive, there's a positive, positive, and then there's a 0 positive, and, yeah, so there's a 0 positive and a positive 0, but, right? So there's something like this. And then there's none of this. Okay, so if we do that, and then we run this again, F4, we have those little locator holes. Now, it's still a little disconcerting, isn't it? Because, well, that 20.75 is, if we made this kind of like exactly this size, right? And so those locator holes, if we made them 1, 2, 3, 4... Yeah, so those locator holes would actually be very close to going all the way through the table. But that's not our table size. Our table size, that was the target size that I thought I was going to make the table, and now that I'm looking at this, I'm like, that would actually have been a horrible, horrible idea. So, let's go to this table border here again. Bad size. Too small. So this table saw, so this 20.75, bad idea. Don't make exactly size. Don't make it exactly the size of the frame, because that's just going to screw us over. So this is really the frame, so we could say FS for frame size, right? And then over here, let's try this one more time. SBC, and we'll just say table size, tabletop size, right? And then 1/4 is just to help us visualize, right? We could make it, yeah, 1/4 is fine to help us visualize what's going on. And then over here, we're just going to say TS equals, instead of 20 inches, 12 and 12 is 24, right? So 12 and 12, exactly 2 feet. So this is exactly 2 feet. Okay, so now let's kind of visualize that. Let's see what we got here. Okay, so that's much better, right? So with this overhang here, these locator holes have a nice little padding here, right? So remember, this is the outer diameter you're seeing here, which is the outer diameter has a 1/2 inch extra than the inner diameter, and that is so that if we V-carve these holes, it'll be really easy to place the pins that we're working with. Okay, so now that we have that, the next thing is just to rotate it and paste here, here, and here. So we have this kind of mirror 12. So the idea of mirror 12 is mirror radially 12 in 12 unique locations, right? That's what M12 stands for. I could say R12, but then that would sound like rotate so-and-so degrees, and rotating doesn't actually do any cloning. Rotating takes the original object and moves it, whereas the mirroring functions keep the original object and then also put it in a mirrored location. For whatever reason, that seems to be my main use case. When I'm mirroring things, I'm usually trying to copy geometry. When I'm rotating things, I'm usually not trying to copy geometry. So, is it a bad naming convention? Maybe. But we need a terse, kind of mirror radially space 12 times. Alright. So, but we need some terse language because otherwise it's just going to be a nightmare. So, SBC is not necessary for these mirror functions, but the thing is that we want to keep the API, if you even want to call it an API, we want to keep the interface pretty consistent. So we're going to start off with, 0, 90, okay, 0, 90, 180, and then 270, I believe, if I remember my degrees correctly. I've been yeah, I mean, okay, well, actually, I have to use it still, so MO4. So we're going to say that wherever we're putting all these holes, so this is where we're putting the holes, after it's translated into place is where we want to rotate it. So we're going to have to put that mirror 04 right here. That takes SBC. Okay, so now if we do that, there we go. So we got all the locator holes, and all the locator holes are in place. We got this nice little zodiac symbol thingy-mabobber. And it's just going to be a unibody, kind of simple frame with no weird features on it. Like, I had an idea to, like, mill these kind of extravagant, like, peg designs that would go specifically into my table. But the thing is that this makes more sense. And we're not going to try to secure it by screwing it together. We're going to hope that because the frame is so kind of heavy duty, that we can just set it down, right? We don't even have to bolt it in, right? So that's kind of what I'm going for. That looks about right. So with this table right here, right, that zodiac circle, right, these pins right here, or these holes right here represent that. So the circle itself, so this logo is kind of small though, right? Because we're talking 5.25 inches. Let me actually just get my ruler so I can visualize what the hell 5.25 inches looks like for a second, so I can get a feel for what this actually is. So it is kind of small, 5.25 inches. And so roughly, and that's 5.25 here. So it's inset a bit. So, oh no, that's the interior. This is the interior. That's not point to point. So in the interior, so yeah, we could roughly say that the symbol itself spans 5.25 inches, which is a pretty decent kind of thing. But you could also say that maybe it'll look kind of classy because it's like, it's not like obnoxiously emblazoned on there. It's kind of like an accent, right? So it's kind of this like sleek linear design. It has an accent piece, right? Which is the person's zodiac symbol. So that's what I want to go with, I think. So we're going to try to just run vcarve on these patterns and get that to work. Now, I am on like a serious budget here, where like my money is running out, and so it might be a good idea to work on the other astrological symbols and get the files together before I start going to MakerWorks again. I'll have to think about it. But this is a good. I feel kind of good about this, but then again, I've drank coffee today because I'm stressed. I missed my push-ups yesterday. I wasn't feeling productive. Just embrace the chaos and then try to have a few months where I don't drink any coffee anymore again, and then hate my life, and I don't know, just... Oh well. Okay, so first thing is we're going to comment out this like locator holes thing. And before we kind of give up here and say, hey, I'm done for the day, we want to make sure that the file looks correct. So, I mean, these dots look correct. We want to create some cutting sheets, actually, is what we want to do. Okay, so what we're going to do is we're going to start moving things to their appropriate files. So we're going to include dot slash underscore dot cut dot whatever cutting files, and then in here this ZODIAC table areas, let's not call it table areas. Let's just call it cut, right? Let's not get let's not get too wordy here. This plan is just for a tabletop. Let's not get so wordy. And then let's just move this into here. Right, cutting files. And then let's just go F4 on here and make sure that the refactor cannot include dot slash cut. So the first thing is, why not? Well, the first thought is that it doesn't like my syntax, that I need to do this. Okay, yeah, so it just doesn't like that. I was just trying to space things out, but I guess OpenSCAD did not like that. So we got these cutting files, and then locator holes and all this kind of stuff here. So I think that we should have include components common. Common components, generic components, right? Something like that. And or maybe generic components. No, let's just call it common. And the locator holes can go in there. Or actually, let's call it Or are we just breaking this into more? Let's stop ourselves from getting ahead. Let's not do this. Okay, let's not do this. Let's not make too many files. I changed my mind on this. Yes, it is fun to refactor things and put them into multiple little files so it's all manageable. But then sometimes it makes things harder on you. So I think we need to just say put common functions down here, right? So common modules, common generic modules. Right, so let's just make a section for this, right? Let's just say, hey, you know what? This right here is called common generic modules, and it goes here. And then anything that's common, right? So the wheel frame is definitely a common component. Common components. Common shared components might be a better word. So, and we could say CSC, common shared components, right? Wheel frame. And then we could go find wheel frame. And it's COM right now, but we could just go find next. Okay, I know you're in here. ZODIAC wheel frame. I know you're in here. Why does it... Don't tell me you're not, because I know you're going to crash on me. Okay, so something's wrong here. So F4. So this... Okay, I'm about to flip a table right now. You're gonna tell me it's not in here. This function called wheel frame, which I know is in here. Aries. Difference. If we look at the cutting sheet, right? Here's the Aries, whatever the heck. Oh, is it in the cutting sheet? Yes, it is. Okay. So, CSC, wheel frame. And then... this should also be CSC. My bad. Okay. So, let's do that. F4. Warning CSC locator holes. Because locator holes... whatever that is... we're going to take this and we're going to rename that, right? So, these locator holes are now going to be a CSC. Replace, replace... get rid of that. F4. Okay. So now the next thing is, we're going to take this, and because I don't want to have to worry about, Sagittarius is much bigger than Leo in terms of how long the name is. So we're just going to say, this thing right here, module, area 01, something like that, and area 02. Right, so this will just call 1, this will call 2, right? We'll give them a name like that, and then in the cutting file, right, in the cutting folder, new folder, we'll make a folder for cutting sheets. And we'll just call this one Airy, right? Airy.scad. And then let's go over here, make sure nothing looks broken on us. So we got rid of the actual code, that code that was doing this, right? So we kind of like moved things. This is a generic whole kind of functiony thingy, so that actually goes in here now, right? Because it's one of those. So put it in the common functions. And then we just want Aries code. And we could do this, but I tend not to do this because it's more noisy, and also my boss looked at that and didn't know what the hell I meant one time, and so now I try to avoid it. And it also does just look a lot less sleek when you write the code that way. So we'll just say, hey, right here, this is the Aries code, right? So rather than trying to break everything into a whole bunch of different files, we're just going to do this. And obviously that does make everything a lot bigger, but it also makes seeking through the file and looking for things a lot easier, right? Because you saw my frustration because some of the stuff was in this thing called cut. Now the question is, does this actually belong in cut? Yeah, I guess it kind of does. Right? These different indexes, sure, why not? So now the next thing is we want to just, let's close this, and let's go open this containing folder, and let's just run this, and generate the things we need from here, right? So no top level stuff to render because, oh wait, because, yeah. What do we expect? There's nothing in here. So I'm going to change this around. So this is actually going to go, those were just wrapper functions, right? So those are just wrapper functions so that we have a nice handle. So the file, we want the file names to directly match a function in the code just for convenience, for kind of we want to be able to connect. Once we make SVG files, we want it to be very easy to say, hey, this SVG file has this name, and therefore it came from probably a function with this exact name, right? So so this wrapper function just is there to help us connect those dots. So if we name something ARI underscore 001.svg, we know it was generated from that function, right? If that makes sense. Okay, so we're going to put that there, and then in this array.scad, we're not going to do that. We're going to call this, we're going to include ... and we're going to include ZODIAC table, so zot.scad, right? We're going to include the top level file, and then we're going to say RE001, right? And it has nothing in it. And then we're going to rename this to, guess what? RE001.scad, right? And so that way, let's take this one and then file new. Guess what? RE002. Save that as re.002.scad. Okay, so now that we have these, we can open those out of the cutting folder and just say, double click that, and debug. We gotta turn debug off. So the debug was there to kind of help us understand what was going on, but we need to turn this off because otherwise our cutting path is going to be all nonsense. So there we go. So this is the top of the table, and this is all we're going to cut. We're not going to cut anything else. We're actually going to start off with square pieces of wood that are exactly the size we need, and we're going to do this. Okay. So now that we have this, we're just going to do File, Export as SVG. And look, re001.svg. So when we see this file, re001.svg, and we're like, what generated that SVG? Well, we know because we have a function that's called re001. So save that. And then we just want to close this one, and then we want to open up the other one, re002.svg, and then render that. Okay, we're just zoomed in too far. Okay, so yeah, and then file, export as SVG. And we're going to do re002.svg is excellent. And save. Okay, so now the next thing is, well, what comes after Aries? And it looks like the next thing after Aries is Taurus. And the Taurus symbol kind of has, what I would say, more spliney kind of curves in it, but we might want to look at other implementations of what torus looks like, and it looks like we could make a torus symbol where we, torus is a bull, right? I think. We could make a torus symbol where the bottom of it's like a circle, the top of it's like a larger circle that's been cut into the bottom third, and then we just put like little lines on it to make little hooks. Let's do like minimal torus symbol, something like that. Yeah. So right, we can literally think of it as a circle with another circle on it, right? A half of a circle, right? Right. This. So when we're trying to stylize it, or this is an interesting stylization. I like that. Oh, look, a little snake. But yeah, there's definitely ways. We have some flexibility in how we are able to do this, right? But we don't want to do something like this, or like this, because it involves kind of weird spline things, right? Or this kind of hook thing. Now, we can... I actually want to see if OpenSCAD has a spline function. And it looks like spline interpolation end spline OpenSCAD. Thingiverse form. Okay, so it looks like you actually have to. You're gonna have to. Oh boy. So. Yeah, I mean you're gonna have to use some other code to like get it to work. SCAD polyline modules. Creating Bezier curves and vases and so okay, so there are like curves of sorts. So if we really needed to, we could figure this out. We could so now is this an inbuilt SCAD function or SCAD functions URL. Let's make a shortcut for that. It's been a while. SCAD functions URL. SCAD func URL. SCAD function cheat sheet. Cheat sheet SCAD. So I think if we just look at cheat sheet SCAD, that'll probably be the URL we want, right? Yeah, so this thing right here is the cheat sheet we want. And from here, booleans, list comprehension, 3D, constants, lists, syntax, 2D, polygon, anything that says Bezier, Bezier, however you pronounce the curve. I think it's like some type of French thing. Bezier curve, I think. Polygon. Okay, well, the other thing we could do is we could just look this up and say, hey, maybe in the official documentation, there's now Bezier, right? Maybe that's an old cheat sheet. Bezier. That's the only thing that says Bezier curves. Nothing else says Bezier curves. Inkscape, better DXF, active native support for Bezier curves. Getting Inkscape. Okay, yeah. So we'd have to do something fancy to get Bezier curves working, as far as I know. Unless this is gonna tell me. Now, why don't I just watch this and then more knowledge, right?
Hello YouTube, and welcome to another OpenSCAD tutorial. In the last OpenSCAD video, we demonstrated the line online model. As promised, I'll expand this by the machine code. Before I go any further, I want to thank Justin Wynn, who might got this idea. He has an amazing website about OpenSCAD at openhome.cc. I'll put a link in the description, so please go check it out. So today, I'll show you the Bezier curve and demonstrate how it can be used to create a face. A Bezier curve is a parametric curve that's often used in computer graphics. Bezier curves are used to model smooth curves that can be scaled indefinitely. The name comes from the French engineer Pierre Bezier, who used them to design automobiles bodies in the 1960s. Examples of programs that with Bezier curve functionality are Inkscape and SolSpace, a 3D CAD program. In a recent video, I used the Bezier curve in SolSpace to create a 3D printable face. OpenSCAD doesn't have built-in Bezier functionality, but due to the nature of OpenSCAD, we can edit. Earlier, I uploaded a video that demonstrated line and polyline modules as a replacement for building polygon in OpenSCAD. Today, we expand the use of polyline together with the Bezier function to create a face. I will make the scripts that are demonstrated in the video available and put a link in the description.
So it sounds like they created the code for this in a previous tutorial, is what they said.
Now to the demonstration of the scripts. Before we move to the face, let us first have a look at a very simple Bezier. It's the quadratic Bezier. And I have a little script over here that demonstrates this. So in the script, we scroll down, we have the Bezier function. It has 3 parameters, these are the 3 points. And this function generates a list of points. And it's calculated with this formula. This is the formula of the quadratic Bezier. So now when I scroll down and put an exclamation mark here. So these are the 3 control points, B0, B1, B2, and the lines connecting them. And when I calculate Bezier, quadratic Bezier, I get this. So this is the blue line. And I'm able to change this line. For instance, if I change the radius of B0, so that's the x value, and I change that to, let's say, 30, that's a 5. So you see that the starting point and the shape of the Bezier changes. I can also change B1, and for instance, I can change the x value to 120. That's a 5. So we get something like this. Or I can change this, the y value, to, let's say, 9. I get this. So you see that I get almost an infinite amount of shapes that I can create with this Bezier. Now this is the script for the face. You probably see it by now, but this is constructed only with the Beziers.
Okay, so okay, so I'm thinking we should probably try to make the designs not use any weird Bezier curves and things, because if we try this, it's just going to be a lot harder to do this. Now, there are some astrological symbols that are kind of like, oh, they're going to be kind of a challenge to get to draw with kind of math, right? We're just luckily on a symbol that's wasn't too hard to do it. Yeah. Okay. I think that's good, though. I think that what I have is going to be suitable. So I think I'm going to stop the stream here. And I'm going to think more about this design. Time is a waste in this, so if this is what I want to do, I should probably... Here's the thing, though. If I need to do this, I'm gonna need to start getting up early so I can go to the shop earlier. And just start cutting material or whatever. I don't know. I don't know. I have to think about stuff. I'm gonna stop the stream just because there's no more work I'm actually doing. Now it's just me having to think about what to do next. So later.